Lipid. How can we define lipid? Here is one example of lipid, triglyceride, and this is a cholesterol. They look like very different. When we define amino acid, the molecule has amino group and acid group, so it makes sense. Amino acid. Carbohydrate is carbo and hydrate. It's a hydrated carbon. The name came from the structure. But how about the lipid? Looks like a very different two molecules. All of them we call as a lipid. Well, the definition of a lipid is a little funny. It's not from the structure. It's from the molecule's property. So we know water and oil does not mix. So lipid molecule is organic molecule which is soluble in oil layer, not in water layer. Those molecules are defined as a lipid. Interesting, isn't it? The main component of a lipid is a fatty acid. Fatty acid has long chain and carboxylate head group, and this carboxylate head group is hydrophilic, and long chain is hydrophobic at the tail. Also, the fatty acid has a saturated structure. Sometimes it has the double bond unsaturated the structures. Saturated structure tend to form this layer very compactly. That's why usually saturated fatty acid tend to form more rigid structures. If the fatty acid has double bond, sometimes multiple double bonds, then those packing became very loose, in a sense disordered the structure. That's why this can form more flexible structures. The common form of food oil is a triacyl glyceride. So this kind of cooking oil has multiple double bond unsaturated structure. That's why it forms liquid structure. Sometimes we want to add hydrogen to this double bond and to make it saturated form. Then this process is adding hydrogen. That's why we call this as hydrogenation. During the hydrogenation, some of those cis form of double bond becomes transform. Usually this transformed fatty acid is not discovered in nature, and that's why we believe that our body has a problem or no experience to handle this kind of a trans fatty acid. And this trans fatty acid is a small amount can be generated in solidified the oil such as a margarine. That's why we worry about maybe this trans fatty acid has some health issues. Now, if you think about lipid as for energy storage, comparing to carbohydrate or protein, usually they have the energy of 4 kilocalorie per gram of the material. Comparing to this number, the lipid has 9 kilocalorie per gram. This is almost the double amount of the energy amount stored in carbohydrate or protein. That's why lipid is the highly efficient energy storage materials. The molecule is also an important component of a cell membrane. The life forms, the phospholipid structure on the membrane has two tails and glycerol and phosphate head groups. So using this structure, it has much stronger the hydrophobic area and much stronger the head groups, more hydrophilic head groups. And if you look at those head groups, the phosphate group has an intrinsic negative charge, and many of the other molecules can be added to this head group, Some of them is positively charged, but some of them is neutral. That's why phospholipid is overall either negatively charged or neutral. It's interesting to see there is no positively charged phospholipid. Now, altogether, the membrane structure is formed by this kind of a phospholipid. But cell membrane is not only composed of lipid, it has a different structure such as glycolipid. Glycolipid, now here, glyco means carbohydrate and lipid is the fatty acid material here. Now, glyco is carbohydrate added lipid structure. Another important motif is this kind of the cholesterol molecule. This cholesterol molecule is embedded in lipid bilayer, and this structure makes the membrane more rigid.